SLIs, SLOs, and SLAs. The building blocks of reliability engineering. Agenda, reliability measurement. SRE history. Why SLIs, SLOs, and SLAs? Error budget lifecycle. Getting started. Basic workflow. Defining indicators and objectives. Reliability measurement. Reliability measurement turns a vague goal like the service should be reliable into a specific, testable number everyone agrees upon. If nobody defines what reliable enough actually means, teams end up debating incidents after the fact instead of preventing them. Almost every production service eventually needs a concrete way to say whether it's meeting its reliability goals. Any team balancing new features against stability benefits from a shared numeric definition of good enough. Chasing as much reliability as possible without a target number doesn't scale into a sustainable engineering practice. Internal objectives and external agreements. A service level objective is an internal engineering target a team sets for itself, used to guide day to day decisions. A service level agreement is an external, often contractual commitment to a customer, typically with consequences if it's missed. SLO internal engineering target guides daily decisions, no formal penalty. SLA external customer contract, business commitment, real consequences if missed. Problems without defined reliability targets. Single point of disagreement. Without a number reliable enough means something different to everyone in the room. Engineers can overinvest in reliability work well past the point where users would even notice the difference. No clear signal for when it's safe to ship new features versus when to slow down and stabilize. Incidents get argued about after the fact instead of measured against a target set in advance. Customer facing commitments get made without engineering input on what's actually achievable. Misses out on a shared numeric language connecting engineering work to what users actually experience. BSLI, SLO, SLA system. A service level indicator is a specific measured quantity, like the fraction of requests that succeed within a time window. A service level objective sets a target range for that indicator, like 99.9% of requests succeed over 30 days. A service level agreement wraps one or more SLOs in a customer facing commitment, often with financial consequences attached. Related concepts in the same reliability practice: error budgets, toil reduction, blameless post-mortems. Advantages of SLIs, SLOs, and SLAs. Turns a fuzzy idea like reliability into a specific, trackable number everyone can agree on. Gives engineering teams a data-driven way to decide when to focus on stability versus new features. Creates a shared language between engineering, product, and customer-facing teams. Error budgets derived from SLOs offer a built-in mechanism for balancing risk and velocity. Makes postmortems and incident reviews more objective, measured against a target set in advance. Protect against both over-engineering reliability and under-investing in it. Everything is measured as a ratio, almost. One huge benefit is that almost every SLI reduces to the same basic shape: good events divided by valid events over some window of time. Availability, latency, and correctness can all be expressed as some version of how often did this behave the way it should. This shared ratio based structure is what lets teams compare wildly different services using the same underlying reliability language. Because the math is consistent, tooling built for one SLI often generalizes cleanly to another. Once you see this pattern, nearly every reliability metric starts to look like a variation on the same simple ratio. SLI, a specific measured ratio of good events to valid events. SLO, a target set for that SLI or a defined window. Defining an availability SLI. An availability SLI is often expressed as a query over recorded request outcomes. Calculating an error budget. The error budget is simply the allowed unreliability implied by the SLO. History. The underlying practice grew out of Google's site reliability engineering discipline, developed internally starting in the early 2000s. Google's SRE team, formed around 2003, pioneered treating operations as a software engineering problem with measurable targets. The concepts were formalized and widely popularized by the Site Reliability Engineering book published by Google in 2016. Error budgets emerged as the key mechanism connecting SLOs to concrete decisions about release velocity and risk. SLIs, SLOs, and error budgets have since become standard vocabulary across the broader software industry, not just at Google. Why SLIs, SLOs, and SLAs? Clarity. A shared numeric definition of what reliable enough actually means. Balance. Error budgets give a principled way to weigh new features against stability. Alignment connects engineering decisions directly to customers and business expectations. Accountability SLAs make reliability commitments explicit with real consequences if missed. Objectivity incident reviews measure against a target instead of after the fact opinions. Broadly adopted, a common vocabulary across much of the software industry today. The error budget. An error budget is simply the amount of unreliability an SLO allows before it's considered breached. A 99.9% SLO implies a 0.1% error budget, roughly 43 minutes of downtime per month. Spending the budget quickly can trigger a deliberate slowdown in shipping new, riskier changes. Never treat 100% reliability as the goal. A small, deliberate error budget is what gives teams room to innovate safely. SLO life cycle. Pick the metric, define SLI, choose the target, set SLO, track continuously measure, Balance risk versus speed. Manage budget. A team defines its SLI, sets an SLO target, measures continuously against it, and manages the resulting error budget to balance speed and risk. Getting started with SLIs and SLOs. This leads us to the three steps that get reliability practice started. Identify critical journeys. Pick the handful of flows that matter most to the users. Define SLI. Choose specific measurable indicators for each journey. Set SLO targets. Agree on a target range the team will track and defend. Basic workflow: measuring, alerting, and reporting. Some call measure, alert, and report SLI and SLOs everyday loop. SLIs are measured continuously, usually pulled from the same metrics already collected for monitoring. Burn rate alerts fire when the error budget is being consumed faster than expected, not just on outright outages. Weekly or monthly SLO reviews keep the whole team aligned on current reliability status. Error budget status directly informs decisions about release pace and risk tolerance. Supports many workflows: internal engineering targets, external SLAs, multi-team reliability reviews. Works the same whether the underlying metric comes from Prometheus, a cloud provider, or a custom pipeline. Any questions? Thank you.